All right, so what's going on, guys? So got a pretty big update for the Galant here. We have finally finished building the engine. That is what I have here under the blanket. If you're new to the channel or don't know, this thing was at the machine shop for almost a year, which kind of led to me doing the all-wheel drive swap. Again, make sure you hit that like and subscribe button. You're going to want to stay in tune to the Galant build. This is going to be a pretty impressive build. I'm really looking forward to it. Also, make sure you stay to the end of the video. I'll give you a sneak peek of the new turbo setup and everything. Right now, I've just got everything bolted on, mocked up. It looks amazing, and we're not even completely done yet. But that's gonna be at the end of the video. As for right now, so like I told you guys, the block was at the machine shop for almost a year. I finally got it back, and with that, I'm gonna go ahead and start prepping it. Now, I will preface this video by saying that this is not gonna be an in-depth video. It's more of an overview of what I'm gonna do. I put a couple engines together before, but I took a couple extra steps. I bought a couple extra tools that I wasn't really familiar with. So I do want to highlight those things and explain why I use them. This is the most expensive engine combo that I've ever put together. It should make the most amount of power out of any car that I've ever had. So I want to take some extra precautions and take my time. So of course, I got the block back from the machine shop. I went ahead and washed the entire thing off. Basic soap and water, pressure washer, get it nice and clean. Then I took my leaf blower and went ahead and dried out everything. You don't want water to sit in those holes. Of course, this is a cast iron block. As such, they are prone to flash rusting. If it flash rusts, you can deal with pitting and other issues that will ruin the surfaces. So you want to go ahead and use a dry air source like a leaf blower to make sure that the block is clean and dry. So after I cleaned it off, of course, you want to immediately, don't let it sit, because again, you have to deal with flash rusting. Don't let it sit. Go ahead and wipe it down with like automatic transmission fluid, WD-40, or light oil, something like that, just to get some kind of coating on the engine block. So after I got the block cleaned and oiled up, I went over every bolt hole on the exterior of the engine with this here. Now, you guys have seen me use this before. This is my thread chase set. In case you don't know, a thread chase is pretty much like a thread tap, but it's not as aggressive. It's meant more for straightening slightly damaged threads and cleaning them out, as opposed to cutting all new threads. So I went over every bolt hole with this. Now, just by looking at this, you can probably tell none of these are going to be big enough for your head bolts. For my head bolts, what I did was actually modify one of the stock head bolts. I just cut some slits in it, and I ran it down into the holes by hand until they came out clean. Now, that's a very important step. You don't want to force it down there because you don't want to cut new threads. You don't want to cross thread anything, especially your head bolts. So I just did that by hand until I could get the bolt to bottom out and the threads came out clean. So after I did that, my next step was to smooth out all the sharp edges on the block. For that, I use this little rotary tool here. I picked this up from Harbor Freight. As you can see, this thing is pretty small and it's actually pretty underpowered, but that made it perfect for what I needed to do. So I wanted to go along the edges of the block and just take the sharp edge off, just smooth them over a little bit. Also wanted to use this to remove some of the casting flash. Now, what casting flash is just, the imperfections left on the block from the machining process. Now, Mitsubishi is going to remove just the bare minimum from the factory, what they need to do to get it running. So you can see that some of these areas are pretty bad. Now, you may be thinking, hey, this block had 200,000 miles on it. If it hadn't fallen off at 200,000 miles, why are you worried about it? Well, it's because we're going to be spinning this thing about a couple thousand RPMs faster than it was ever intended to from the factory, and putting it under a lot more stress. It's going to be making, 3-4 times the horsepower. So there's a lot more heat that's going into it, and we really don't want to have any of that stuff potentially break off and fall down into the engine and cause it, and cause damage to it when it's something that we can avoid. So really, it only took like 10 minutes. Like I said, this thing was pretty cheap. I think this was like 20 bucks. Again, the link for all this stuff will be down in the description because it is so small and underpowered. It's really easy to manage, so you don't have to worry about damaging, those machine surfaces. I also went ahead and smooth out this oil passage here. As you can see from the factory, it's more of a 90-degree turn. We're going to take a little bit of that corner off and just smooth that over so that the oil has a much easier path to get into the engine. Now, I've never seen any scientific data that proves whether or not this is effective or beneficial, but if you look at just the way things flow, it just makes sense to make the path easier as opposed to having to make that hard 90-degree turn. So after all that, we need to, of course, protect the blocks. Of course, this is an iron block and it will rust over time. So normally what I've done in the past is just use a spray high temp paint that you guys are all familiar with. Again, you can get it pretty much at any auto parts store, but I did a little bit of research and kind of went down the rabbit hole on YouTube, and I decided to go with this stuff here. So what this is Rust-Oleum. This is rusty metal primer, and this is, of course, is aluminum. Now, apparently these will hold up a lot better than the spray can, and they don't cost that much. These cans are $15 a piece, and you could probably do a dozen or so blocks with these cans. So definitely, I think, worth the investment, assuming that it does work. Before I actually went ahead and painted the block, I used a torch to heat the block. Again, this is something I've never done before, but apparently it's supposed to remove the oils that are in like the porous surface of the block. So over time, it can absorb oils and coolant and stuff like that. So apparently this is supposed to burn off anything that's under the surface of the block and make the paint stick a little bit better. So I went ahead and took my torch, went over the entire block a couple times. Then I hit it with the rusty metal primer and then the paint. I put a couple coats of each on the block. So once all that was done, I was ready to start the engine build prep. Basically, we're trying to get each rod and piston combo to be as even in weight as possible. So there actually are variances between each piston, each wrist pin, and each even ring pack. And it really depends on how in depth you want to go with this. Like from what I could find, most people agree that 0.3 of a gram is really good. So that was kind of the number I was shooting for. I bought this scale off Amazon that went down to 1/100 of a gram. And when you buy on a scale, you may be concerned with the accuracy. But what you'll find is that when you're doing this, the accuracy is not as important as the repeatability. So as you can see from my big piece of cardboard that I have here, that I weighed each piece multiple times. Like, unfortunately for me, very little had to be done. Once I combined the pistons with the wrist pins and the ring packs, they were all pretty much within spec. Now, the rods, unfortunately, I couldn't do ahead of time because I don't have the jig or the tool for it. Once I got my pistons and everything to a point where I was okay with it, we went ahead and load everything up because we're going to head down to Trey and we're going to go to his garage and he's going to help us finish putting the block together. And he's actually got the tool that you need to finish balancing the rods.
A few moments later.
So just like that, we made it to Trey's house. We laid out everything we had on top of the toolbox just so we could account for everything. Then we went ahead and got to work. So I pulled out this jig that I was talking about. And what this jig does allow you to take the rod and then weight each end of it. And it does that just by supporting them one end, which allows you to just pretty accurately weigh just like the dead weight of the other end. Like, and you want to do this just because the small end, the side that's connected to the piston, isn't really moving a whole lot. It's really just going up and down the bore, where all the reciprocating mass, the important part of it, is going to be attached to the crank. That's your big end. So with the rods, them being steel, there was a much greater variance in between each one. So we will actually have to do some filing, some light filing in a couple areas, again, on the big end to get these to match up. So we measured all the rods multiple times. Once we were happy with the numbers that we got, we went ahead and matched them with the pistons. Of course, you put your heaviest rod with your lightest piston to try to get an even combination across the board. So next we pulled out the dowel bore gauge. So this wasn't a tool that I was really familiar with. I have never actually used one before, but I did my research again, just looking on YouTube, found a good quality dowel bore gauge, and then watched a bunch of reviews and like how-tos on how to use it. So now if you look back at the clip of everything laid out on the toolbox, you notice that I do have a torque plate. So now what the torque plate does is simulate the cylinder head on top of it, because the cylinder head, once it's torqued down, will actually change the shape of the bores very slightly. So this being an iron block, it actually didn't deform too much, and that helps when you have the block machined. Of course, you want to keep the bores as round as possible, so you pick up a torque plate, take it to your machine shop, they'll install it, they'll bore it with it. When you go to measure them, you'll have to put the torque plate back on to make sure that you get an accurate measurement, because it will be slightly different. Of course, it's being an iron block, it wasn't a whole lot of difference. I'm really just kind of showing you guys how it's being used here, and it's harder to see with the torque plate installed. Like, so next up, we're going to go ahead and install the crank. So for this, we flip the block over and we go ahead and install our bearings first. You don't want to put any assembly lube on the back of your bearings because the bearings shouldn't be moving in the block. You only want to put lube on the areas that'll have metal to metal contact that'll be spinning, like again the crank sitting in the bearings. Also note that when you install your thrust bearings, that those grooves in your thrust bearings should be facing outward. After that, it's pretty straightforward. You're just going to set the crank in, put your girdle on, and go ahead and install your studs. And as you can see, I am using ARP main studs here, so you want to follow ARP's suggested torque range, and of course follow your OEM, your recommended torque sequence. So one thing that was a big help when installing really this entire thing and putting this whole engine together was this guy here. This is a little T-handle. This one's by Michael and Pro. I think this is like a cheaper or knockoff version, but it actually worked really well. So this bottom part is adjustable. It can move up to wherever it's comfortable, and it has ball bearings in it that allows you to spin it easily. So this makes sure you can get things hand tight while taking a little bit of stress off of your hands. Like, so I actually really like this. I've actually used this quite a lot since I put the engine together. So of course it does have two ends. Of course you have your main end that you're going to use, and you have this end down here which allows you to use it to get a little more leverage if you need to tighten or loosen something. But again, this thing is perfect for hand tightening threads. It makes it a lot faster. I know it doesn't seem like a big deal, but like I said, I've used this thing quite a bit since I finished installing the engine. All right, so next we're going to go ahead and install the rods and pistons. Now I didn't record me assembling the rods and pistons, but it is pretty simple. You just put the rod and the piston together and slide the wrist pin in, and then you're going to need like a small screwdriver or something to help get the clips, the little C-clips on the end that secure the whole thing together. All right, so the next step is going to be to install our rods and our pistons. So before we do that though, we want to get our rings gapped. So for that, you're just going to want to take your top ring for your piston and you want to put it down in the bore. I used the top of the piston, and I found a mark on it which was about 1 inch deep, and use that to measure how far down the bore we were going to push it. And I use that so I can get a consistent measurement. And you just want to take your feeler gauges and just measure the gap. Now again, I know each piston manufacturer has a recommended spec they want you to go on. I would recommend going on the looser end, especially if you're making higher power, because those rings will expand as they heat up. And of course, you don't want them to be too tight and they butt up against each other and you blow your motor that way. You can get a cheap piston ring filer off of Amazon. They all pretty much do the same thing. The only big thing there is before you install your piston rings on your piston, you want to make sure they have no sharp edges and that the edges are even and they're not tapered at all. So when you go to install your pistons, you're going to need something like this, which is a piston ring installer. Like, so what this will do is allow you to safely spread the piston rings apart and slide them onto the piston. Like, you can do that by hand, but you risk breaking them, and it's just not worth it because, again, this is a pretty cheap tool to allow you to do it worry-free. So next I went ahead and installed my bearings into my rods. You want to do this before you put them in the block, just because you won't be able to reach them once it's in the block because the crank will be in the way. I didn't mention this earlier, but what I am using is this assembly lube here. This is a moly and graphite engine lube. And the reason I went with this is because it's more of a paste. The other ones that you normally see are like a red, almost like syrup type consistency, and they will drain off. Now, I'm not sure how long the engine is going to end up sitting here before it actually gets oil pressure, so I didn't want to risk, the assembly lube being pushed out and draining into the oil pan before I got a chance to run it, because then essentially you'd be starting up a dry engine. This stuff, like I said, is more of a paste and will stick to the bearings and it won't go anywhere. So after we've got our piston rings installed and everything's ready to go into the block, you're gonna need a piston ring compressor, of course, to compress those piston rings so you can slide them into the block. Now that you have two options. You have like this adjustable kind. Again, you can pick this up at an auto parts store, and I have used those before and they do work. But what I found doing my research is actually something I like a lot better, was this guy here. And what this is a tapered ring compressor. Of course, this one in particular is made by Weisco. And what this is just what I imagine is aluminum ring that is specific to your bore size. This one is for an 87mm bore. Now, the adjustable spring compressors, they do work, but I think since I've used that, I've been converted, I think I'm going to use exclusively that. The only drawback to something like this is, as you probably already figured out, it's bore specific. So if you're working on a bunch of cars, you're going to have to buy one compressor for each individual bore size that you're going to be working on. And that can get expensive because those do run about $50 a piece. Now for me, I went with this just because I was curious. I had never used one of those before. I figured that any block that I get, I'm going to bore 20 over. Because of course the factory bore is 86.5, just to make sure that the bores are straight. And after that, it's just a matter of pushing the pistons all the way down, connecting the rod cap on the other side. So when you do this, you also want to check and make sure that your bolts are torqued correctly. So on these Manley I-beams, they actually have the upgraded ARP hardware, and they give you really two choices. They give you a torque sequence and a rod stretch length. And basically what the sheet says is if you torque it to this amount, you should get this amount of rod bolt stretch. Now your rod bolts are one of the most important pieces in your bottom end, because in a bottom end like this, the rod itself is not going to break. If anything does fail, it's going to be the rod bolt. So I went ahead and picked up this guy here. Is a rod stretch gauge. And what that does, it allows you to measure the exact stretch of the bolt after it's been torqued down. Now what I noticed is that the torque specs provided with the rods are pretty much spot on with the amount of stretch that they recommend to be in each bolt. But it's just a good way of double checking. And I figured a tool like that was worth the investment. After I had everything together, I went ahead and turned it over by hand. Make sure that I don't have any binding, any odd noises. Went ahead and got it packed up, took it back home, because unfortunately at this point, the cylinder head wasn't done. So while I waited on the cylinder head to be done, I went ahead and got the short block back on the engine stand at home, and I started installing the parts that I could. So I got a whole new front case. This is different than the one that was on it. I got a brand new Mitsubishi gasket. And what you'll also notice is this AN fitting that Trey actually welded for me in the top of the front case. And what that is that's going to be used as a crankcase vent. So eventually I'll run a hose from that probably to my catch can, and it will help relieve any pressure that builds up in the bottom of the engine. And pretty much everything else you see on the block at this point, other than the front case, it's just hand tight. I wanted to make sure I had all my parts together in case I was missing anything. Shortly after I got everything together, the head was finished and I was ready to complete my long block. So for head studs, I went with L19s. Now L19s are really strong head studs with a really high clamping force, but they are sensitive to water. So when I went to install it, I made sure I had some gloves on. And again, you just want to tighten everything down hand tight. You don't want to bottom out the bottom of the stud in the block, because just like everything else, they will expand. For the head gasket, I went with this unit from Cometic. It is for the stroker setup with the 64 block, and of course that slides right on. You want to make sure that all your ports line up because you can install it upside down. So I went ahead and set the head on. You should be real careful because you can damage the head with the head stud. Like so from there, I went ahead and got the head torqued down. As you can see, I wrote the torque sequence down on the head with a permanent marker just so I didn't have to keep referring back to a picture. At this point, we're on the home stretch. You just want to drop in your lifters. These are GSC zero tick lifters. Then your rollers, which are just the OEM rollers. Then I got these GSC S3 cams. These are the billet cams. And with that said, we're pretty much done with the long block. So if you're watching to the end of the video, I do appreciate you staying. I'm going to go ahead and give you a sneak peek of everything that I got laid out so far. I will give you guys a complete breakdown of the engine as far as what parts I use and how much everything costs in my next video. Like I said, guys, here is your sneak peek. As you can see, there's a lot of upgrades and things looks a lot different. This is the same valve cover that was on the car, but this will be coming off because I'm not happy with the powder coat because it's cracking. But this is pretty much an all new setup that's going to be on this car. So once again, thank you guys for watching. If you haven't already, hit that like button, hit the subscribe button. Have a great day.